Hey, Joel, can you hear me?
No. Just kidding.
Hey. All right.
I can hear you, Michael.
Cool. Just give everyone a few minutes to show up. Hey, everyone. We're just going to give the others a minute or two to join. Joel, you have everything ready on your end?
Yeah.
Exciting. All right. We'll hang out for a bit more. Good to see some familiar names, some new names.
Hello, everyone.
Hey, Michael.
Hey, Sean. Sorry if there's any background noise on my side. A bunch of people around the house today.
Show Emmy while we wait.
All right, come here. Just took her out. Got a new puppy. He says hi. She's a big fan of IPFS.
You've not convinced her to be a fan of ceramic yet?
She's there already. She was born a fan of ceramic. All right, cool. So we're 2 minutes in. We're booked for an hour. We may or may not use the time, I think, depending on how many questions there are at the end. But it's great to see everyone. Thanks for joining. This is sort of the follow-up to last week's kickoff call, where we just gave an overview and intro to ceramic. So we're going to keep it pretty light on the general overview content, but if you're interested in that content, we posted a YouTube video recording of that call. So Rachel or Danny, do you guys mind grabbing that link and sharing it in the chat? So if you feel you need an overview, it's there. So the general agenda is we'll spend 5 minutes again just reviewing ceramic for those that are new, before you sort of dive into the hour-long video that gives the full overview, and then I'll turn it over to Joel, who will walk us through the specs. So general specs of ceramic and the protocol and documents, and then particular document types that we have. Then we'll do a demo, and then the rest of the time is for questions and discussion. So that's pretty much it. Yeah, YouTube link to the overview is in the chat. So yeah, about ceramic. Again, I'll keep this quick, but ceramic is a protocol for creating unstoppable documents that are signed by DIDs, that are append only, so they're versioned, which makes them censorship resistant and tamper proof, and they have permalinks. So basically like a doc ID never changes. So you don't have the same problems that you have with like HTTP. There are a lot of use cases for this type of a system where you have these signed append-only documents that are anchored on one or more blockchains to give them verifiability and consensus. And so we've been starting to explore some of those and how ceramic can be utilized by a system like 3Box, or sort of utilized by systems for other use cases, like self-sovereign identity networks, interoperable database networks, permissionless web services where you don't need to create accounts and sign up for each individual service, but rather you can discover the requirements for interacting with an endpoint from the network and then just interact with it if you meet those requirements. And so a lot of other use cases for generalized permissionless version publishing of information. And so some in the community have already started to explore that. But I'll sort of keep it there. Happy to answer any quick questions if anyone does. But if not, then we can start to dive into the technicals.
Cool. All right, so today I'm going to be going through the specifications of ceramic, and after that I'll give a quick demo of the protocol itself and the proof of concept implementation we have. So I posted a link to the spec, but I'm going to share a screen as I go through it. And feel free to interrupt me with specific questions for like any parts as we go through, if things are unclear or if you're wondering something specific. All right. Cool. So yeah, this is the repo for the specification. Michael already gave a pretty good overview. So yeah, we have created a protocol for tamper resistance updatable documents. And each document is signed by some owner or owner of the document, and it's blankered on a blockchain. So it can be anchored on any blockchain, but usually we try to have one specific document be anchored on a specific blockchain, and I'll go more into that later. And then there are different document types, and these different types have different kind of update rules or kind of state transition rules, and we'll dive more into that as well. This whole protocol builds on top of IPFS, and in particular a system called IPLD, which is short for interplanetary linked data, and it's the kind of data structure that's used within IPFS. And in addition to that, it's also built on blockchains, and we're focusing right now on adding support for Ethereum. But really the protocol can support any blockchain like Bitcoin, Cosmos, Polkadot, and what have you. So a document and the cool thing about the ceramic, if you contrast it to like a blockchain where you have like, in Ethereum, for example, you have like this whole state of the entire blockchain, and you kind of need to sync the entire blockchain just to get the state of like one specific contract. In ceramic, it's different. You can sync the state of only the document that you're interested in, and you only need to like verify a specific proof that a blockchain anchor was included on a blockchain. So that means that you don't have to care about like any other documents than just the specific documents that you care about, and you can get the updates for those documents. Okay, so each document is an append-only log, and first we create a Genesis record, and yeah, I'll kind of go through the document lifecycle. But yeah, we create a Genesis record and then add a signature record, and this signature record includes an update to the document. And once we have an update to the document, we have a service that anchors this update on a blockchain, and then we can keep iterating this, and we have kind of this document that's updating as kind of the users that control the document or own the document make additions or changes to the document. So in order to create a document, you basically just create this Genesis record, and this record is added to IPFS. And from IPFS, we can get something called a CID. And you can think of this as like just the hash of the content of the document. And that's a document identifier, and it never changes regardless of how many updates you make to the document. So how do you update a document? So documents are updated with signature records, and depending on the document type, the way signatures are done might vary. And I'll go through that in more details as we get to the different document types. But basically, we have a signed record that contains the change to the document. And yeah, that's it. The change to the document and the signature. And then it points also to the previous record, in this case, the Genesis record. And as we kind of make the signature record, we also make a request to an anchoring service to get an anchor. So an anchor is really just a pointer that adds like a reference to your document on the blockchain. And we'll go through more about that soon, of like how that can scale. And yeah, once the document has been updated, the update of this particular document is gossiped in something called PubSub in libp2p. So libp2p is the underlying peer-to-peer network protocol that's used by IPFS and Ethereum too. Yeah, so and then other nodes that are interested in the same document can listen for this update and get that update. But what if you want to look up a document that someone else has created and you only know the ID of this document? So what you can do then is make a request to the network, and other peers or nodes that have this document locally can send you the update that says this is the latest head, and head meaning the CID or the hash of the latest update to this document. And then this node can sync the document, verify that the signature and the anchor records are correct, and then know that they have the correct state of the document. Yeah, so that's the general life cycle of documents in Ceramic. And now I'll kind of go more in details on like all of this. So right now we have specified the document identifiers to be either Ceramic :/ and then the CID of the Genesis record. We also sometimes use /ceramic/ and the CID of the document record. And this identifier never changes. So even if you make like 1,000 updates, you will still use this identifier to get the latest date of the document. And we also, so yeah, here's an example of what it might look like. And we also have a concept of versioning, or like referring to a specific version of a document. And in this case, we would do CID of the Genesis record, and then we have this version parameter, and then refer to like a specific anchor record. So in this example here above within this image, if we want to see this version of the document, we would say Ceramic, the CID of the Genesis record, and then version and the CID. All right, so how does this document log work? Well, I think the image above made it fairly clear, but basically it's a log, an append-only log of IPLD or IPFS objects that are that all have a pointer to the previous record, and that kind of builds like a list that links to itself. So if you have the latest head, you can verify and sync all of the data back to the Genesis record. Let's see. Oh yeah, so one thing you might ask is what happens if there are two competing branches of the document log? And then like you might get two heads from the network and from like one malicious peer that gives you like an incorrect head. And then like what you can do is you can compare the blockchain anchor records and the update rules of the specific document type. And from that, you can kind of verify that the state transitions are correct. And using the anchor records, you can verify if there are two correct state transitions, you can verify like which one is the actual one that was made first. So the blockchain gives us like a strict ordering of these updates. Yeah, so I'll dive a little bit deeper into how this blockchain anchoring work, because obviously if each document were to be anchored and send a transaction on chain, that would like be kind of expensive and kind of limit how many documents we could kind of effectively have on the network, since like most blockchain, or I think all blockchains have like very limited, or all like really decentralized blockchain have a limited amount of transactions you can do per second. So what we do is we introduce an anchoring service that takes a bunch of document updates from a bunch of different nodes and creates a Merkle tree. And in the leaves of this Merkle tree, we have the signature record, the update that we made to the document. And then it takes the root of the Merkle tree and puts that on the blockchain. And one interesting aspect of this is that we put the entire Merkle tree into IPFS, which means that we can sync actually the Merkle witnesses or the Merkle branches for specific proofs. So if I make an update and like 100 other peers make update on in the same Merkle tree, I can actually just sync the data in my specific branch of that Merkle tree, which is kind of nice. And the kind of top or root of this Merkle tree will be like collaboratively pinned by all of the different users and document nodes that share the same Merkle tree. Yeah, I think I touched a little bit on this concept of conflict resolution. But basically, if I have two conflicting branches and they have correct state transitions, how do I know which one is the one I should look at? And then we look at, is there one of the anchor records on the blockchain that happened earlier? And if it's, and then we take the earlier one and use that as true, and disregard the ones that came later because that could have been created by someone else. So this is useful, for example, in 380, our identity, decentralized identity built on top of Ceramic, that if you rotate a key, you might lose that key at a later point, and someone might steal the key and make a valid update to your DAD document. And even if that happens, like we can see that the rotation that happened earlier is the correct one, and the later one can be discarded. All right, so one possible attack on this type of thing could be that I create two updates, and one of them happens earlier and one happens later, but then the one that happens earlier, I kind of withhold that data and don't tell anyone about that update. Now, people would think that my later update is correct, and any signatures that I make using this in the case of an identity could be like valid until I reveal this data, and then all of those signatures would be invalidated. But in the case of identity, this is actually not a problem, and it's actually a feature, and I'm going to tell you how. So the problem is really not a problem because all the kind of things you have built up is associated to your identity with the signatures that you've made. If you were to revoke that, then the only one that's getting hurt from that is really you. And the other thing is like one problem with like identities on blockchains is that you can kind of sell your identity because you can just like send it to someone else or give someone else access. But here, if I do that, if I give someone, rotate the key and give that access to someone else, they have no way of knowing that I don't have like a rotation that happened earlier and was withholding that and not telling anyone about it. So if they buy it and pay me money, and then I just rotate it back to my keys, like I can totally fool them. So that's actually a feature of an identity protocol that we can kind of remove the ability to kind of sell an identity. Another thing I wanted to quickly touch on is like, what happens if I anchor a document on two different blockchains? Then we have to be more careful because if we anchor just on one blockchain, we can just measure the block height to see which one is valid. But if we have two different blockchains, there's no like strict ordering between two blockchains. So we have to rely on the block timestamp, which is somewhat unreliable. So we are kind of discouraging anchoring one specific document on multiple blockchains. I saw there was a question maybe in the chat. Let's see. Okay, that was not a question. Cool. So I'm going to go through the different records that I briefly mentioned above. So the first one is, so all these records are stored in IPLD and kind of structured in a way which links in these records are like, you can follow them using the IPLD and IPFS system. So the Genesis record, this is kind of the generalized one, and it has specific rules depending on which document type you're using. But the general one is, there's a doc type, which describes which document type and kind of which state transition function to use. It specifies the owners, and the owner has like different, you can have different types of owners depending on the document type. And then the content is just like some form of JSON structured content. All right, so the signed records are similar, but they instead of but they have like a previous pointer. So the previous pointer contains the CID of the previous record, this points in this case it would, or if it's a first update record or signed record, it would point back to the Genesis record. And then the content in this signed record, and I see a question in the chat that's like, what if the JSON structure of content needs to be updated? Yeah, that's a good question. So like if we put some data here, and we want to update that data, how do we do that? Well, basically we just put some other content in the signed record. And depending on the document type, there are different rules for how these updates are applied. All right, so anchoring records are a bit different from signed records. Oh, I guess on these signed records, I forgot to mention that in the proof of concept right now, we're using JWTs, and that's the JSON Web Tokens. We're looking at building something that's more native to IPLD and using something called YOSE. So that's JSON object signing and encryption. And that would allow us to like have kind of more native IPLD structures that can both link to other things, but also include a signature and like a verification function. So that's like for most signatures, but the account link doc type will have a different logic for how signatures are done. So the signatures might vary depending on which doc type you're using. All right, so the anchor records are a bit different, and these are the records that kind of verify kind of when this update happened, so and when they were anchored on the blockchain. So it's a little bit more involved than the signed record, but basically it has a similar structure. So it has a previous record, and then points to the previous event in the log, or like record in the log. And then we have a proof, and that's another IPLD object, and that kind of is this object down here, which I'll get to in a minute. And yeah, I see there are questions. I'll just go through this part, and then I'll get to the questions. The path is basically the path you take in the Merkle tree to find the proof for your document update. All right, so this proof object here contains Shane ID, and to represent the Shane ID, we're using something called Shane agnostic improvement proposals, and they have a proposal for how to represent kind of any blockchain using a Shane ID that describes the namespace and then kind of which blockchain in that namespace it is. So you can refer to Ethereum, Bitcoin, and like different Ethereum networks and different Bitcoin networks and different Cosmos and Polkadot networks. I think those are the ones that are supported right now, but it's easy to kind of add more blockchains into this standard way of addressing blockchains. And then we just keep some metadata about this timestamp. Then we put the blockchain hash, and this is basically the hash that of the transaction which this anchor was included. And then we also have the root of the Merkle tree. So this kind of looks like this. So this large one here is this record up here, and this proof here is this record. So in this anchor record, we have a next pointer, and this points to the previous. Oh, sorry, I haven't updated this. This should be previous. Sorry about that. And this might be like a signed record. Now, we want to prove that this record that happened over here has also been anchored on a blockchain. So we have this proof, and using this proof, we can find the blockchain transaction. That's like the hash of the transaction here. And now we also see that, okay, so this root that's here is included on the blockchain. And now we can use the path that we have from up here to get to the same, go through the Merkle tree and get to the record that was anchored on the blockchain. So we can, using this, verify the path. So we see here that the path is the green one. So in this case, it would be, we go from the root to right, and we get the next record. And I mentioned before that this will allow us to kind of collaboratively pin this Merkle tree and also this proof metadata. So if there's another document that was anchored on the same Merkle tree, they would have a different anchor record that has a different path and a different next. And maybe they would have the path right, left. So they would also pin this proof metadata and pin this Merkle root and this IPLD object and that IPLD object. So we would kind of share some of the burden of like pinning this data. All right, so I'm gonna have a look at the questions. Is there an incentive for anchoring services to be well-behaved? What prevents them from dropping changes? So there is nothing right now that incentivizes the anchoring service to behave well, other than them being like a reputable service. So right now we're building like the first anchoring service, and that's something that will be run by 3box. But there is nothing stopping anyone from like creating their own anchoring services. And if they don't trust like our anchoring service, they can create their own. Or if they want anchoring on another blockchain, they can create their own as well. We're kind of building our anchoring service so it's easy to kind of switch between different blockchains that you anchor on.
And also, it's probably worth noting that users themselves can directly anchor their own transactions. It doesn't necessarily have to go through an anchoring service. That just provides scalability and ease of use.
Yeah, exactly. So that's a very good point. Another question, does the owner's string have any meaning, and are there arbitrary strings? Yeah, that's also a good question. So this owners here of the Genesis record, and I'll get to that now, basically, because we're jumping into the document types. All right, so we have created 3 different document types, and it's possible to add other document types if there is like need for it. And if you have like ideas, feel free to like create an issue here or on this repo, or create a PR or something like to let us know like what you're thinking. But let's start with 3ID. So 3ID is like a self-sovereign identity that's compliant with the DAD standard, and it's implemented using Ceramic. And if it loads, all right. So yeah, basically all of these doc type descriptions are similar, and we'll go through how the Genesis record has to look like and what a signed record has to look like, and which rules apply when updating. So in a 380 document, the owner have to be SICP256K1 public key. And then we have to have, in content, we have to have a signing key, and that's also a SICP256K1 key. And then we also have an encryption key, and that's just like an X25519 key. And this basically allows us to have a specific owner key that makes updates to the 3AD document. And the identity, when the identity signs something, this other public key here is used for signing. And if you want to encrypt something and send that to the user, then you would use this public encryption key that's specified here. Okay, so a signed record in a 3AD document contains a pointer to the previous record. And the content is structured as a JSON patch object. So JSON patch is like a standard for like how you specify changes to a JSON object. And right now we have specified the update rules of the 3AD document to be very general. So you can basically change any of the content in the document. And if you change one of the public key, then that's kind of like a key rotation. All right, so there's another question in the chat. How do you deal with when append-only logs become really large? Any strategy to coalesce all these changes into a single element? And then the other one, maybe with snapshots. So yeah, that's something we're thinking about, but we haven't specified exactly how that will work yet. But basically, we could think of a system where we create snapshots every like 10 or 100 updates. But also, as we've been thinking with Ceramic, is that really right now it's built for kind of this slow pace update. So if you want to do like more collaborative applications or something like that, you might use Ceramic as kind of the base identity layer and some kind of structure to route to different data providers that might pin your content. And then you might use something like OrbitDB or Textile to kind of have more fast-paced collaboration on things. But yeah, we're definitely looking at how we can like do snapshots and how we can do that in a secure way, because right now we have to kind of verify the whole chain in order to see like which of these anchor records that happened later in the history which ones were the correct updates. But we're thinking about like how that can be like consolidated into like a system that has snapshots as well. All right, so there's another comment in the chat. So perhaps CRDTs on top of Ceramic, where data is persisted in Ceramic periodically. Yeah, either you could build a doc type that supports CRDTs, but right now we only have like one append-only log, and it's like forced to be one log. An interesting thing though could be if you have like fast-paced. I think that's what you meant, Andrew. Like fast-paced updates, and then periodically you kind of store these updates in Ceramic. So like you make a bunch of changes, and then every hour or something you kind of snapshot it in Ceramic, and that gets timestamped on the blockchain. So that's a really cool idea. All right. Yeah, DIDs also have like a specific format for their identifiers. So instead of just the normal kind of Ceramic / CAD, the DID can also be, the 3AD can also be referred to by DID : 3 : and the Genesis CAD. And an example of this is kind of still might change, but basically we might have like public keys, and we might have additional information in this 3AD document. Let's see, how are we doing on time? We're halfway through. Okay. Let's go back. I think we're almost through this. Okay. So another document type that's is really cool is called tile. A tile is basically a way of storing like any type of data that's and a tile is owned by one or multiple DIDs. So we've kind of designed the Ceramic protocol to have 3ID as like one of the identities, but you could also use other DID methods. So DID is a standard from W3C, and there's a working group that's like building a standard way of kind of talking with DAD identifiers. So there's, for example, one called FR, which is using kind of more the Ethereum blockchain directly, and that could be used within Ceramic as well to make these tile documents. So a genesis record of a tile document is a doc type tile, and the owner is a DAD. So here in this example, we have a 3ID and it has some CAD. And then the content is basically, can be anything. And this is very similar to how the 380, the signed record is very similar to the 380 updates. So we have previous record. This is signed using these JSON object signatures, and the content is a JSON patch. And the update rules for a tile is basically it can change anything in the content. And if there are multiple owners, or if there's more than one owner, then all of the owners need to sign the update before it kind of becomes valid. And we have some examples here that might be interesting. So we even think like, what can we use this for? So one thing we want to have as we use this with Treebox is like this concept of collections that we can kind of refer to Orbit databases or textile databases, and we have like a collection that's maybe one collection could be used with one app, and then you have another collection in another app, then you might have a third app that kind of pulls in to both of those collections and like aggregates the data somehow. And yeah, so that's how we're thinking about that. So here in this example, we have a collection that's owned by this DID, and it has these types of databases, and it has a tag. But really, you can store like any JSON formatted data. A service policy is another concept we have for basically describing a REST endpoint or some kind of service. So in this case, we have a service provider that creates a tile document, and they basically describe myservice.com, and they have request a timestamp, and they can resolve a timestamp. And there might be like some schema for the parameters and some schema for the results that you get back from the service. Also, one thing that we are building with Treebox on top of Ceramic is privacy tiles. So privacy tiles basically allows us to store references to a user's database, and kind of also encode like who is allowed to access this database, and we can add additional encryption on top of this as well. So basically allowing more secure and private storage of data on top of IPFS. Cool. All right, so we're gonna go through the last doc type. This is basically an account link, and an account link allows us to link a blockchain account to a DID. And basically, it's fairly similar to the above. It has a different way of doing signatures, but the owner in this document type is a chain agnostic improvement proposal 10. And that's basically a way of referring to the blockchain, any specific blockchain, and any account on any specific blockchain. So you can kind of refer to any specific accounts on any blockchain that exists. And right now, I think it supports Bitcoin, Ethereum, Polkadot, Cosmos. And yeah, a signed record is a little bit different here, because we sign just a normal signature for the specific account type, and that might vary, but it's not using the same kind of JSON object signatures as before. So in Ethereum, this would just be like a personal sign, if you're familiar with the Ethereum lingo. And then an Ethereum link might look like, so this is the owner and Ethereum address at the mainnet, and Polkadot, this is a Polkadot address at some Polkadot chain, and then they point to the specific 3ID. And yeah, Cosmos, Bitcoin, different ways. I assume this is mainnet. I don't know. All right. So the last part here is describing kind of how the updates are propagated in the network. When I make an update to a document, yes, the question in the chat, EIP155:1 is a type thing. That's exactly right. It's a really nice way of like addressing like multiple Ethereum chains or like multiple other chains as well. All right, so when we make an update to a document, we get a new head. That's the kind of latest update to the document. And then we gossip this update to the network. So we send a message using a libpdp pub/sub in a topic. Right now we're using Ceramic as the topic. With an ID, that's the document ID, and the CID, which is the CID of the head record. So any other nodes that are interested in this particular document can filter for this document ID, and then just apply, sync the log from this head, and apply this log to their local state of their document. And similarly, you can send a query for a specific document and get a response in this format. So there's some kind of limitations with this that we're going to address as they become a problem. So basically having one pub/sub room for like all of the documents in the network is not going to be scalable, but it makes sense to do that now as the network is kind of really small. But as the network grows, we can kind of simply shard the namespace of all the document IDs into like multiple different pub/sub topics. And then just briefly on Ceramic services. So I touched upon this when I was going through the tile document type and also the anchoring service. So we will create like tile or documents that describe the service. So the anchoring service, for example, we'll create like, this is the interface and this is the endpoints you can use to make requests for an anchor. And this is the format of the data you can get back. And that kind of generalizes to any type of service. So on Ceramic, we can have like a decentralized kind of index of a lot of different services. And these service policy tiles that describe the service might like include, in order to use this service, you might need to make like a micropayment using Bitcoin Lightning or using Ethereum Connect or something like that. Or you might like need to create an account somewhere. But I think the really cool use case is when we can kind of combine these service descriptors with like a way of doing micropayments. All right, so that's it for going through the specs. We have 15 minutes left, and I wanted to give a quick demo of the CLI tool we have. And then we'll open up for some questions. All right, so can you see my terminal right now? And is the text kind of okay size?
Yep, you can see it.
Cool. All right, so the first thing we're going to do is we're going to start the IPFS daemon. So right now running Go IPFS with pub/sub enabled.
Could be a bit bigger, Owen.
Sorry, what was that?
The text could be a bit bigger.
Okay, I can zoom in a little bit. Let's see, we're not going to do too much on these terminal windows. So I'm just going to run Ceramic daemon also. So the daemon creates a Ceramic node instance, connects to the IPFS, and it creates a user DID. All right, so I'm going to zoom in here a little bit. Clear. Is that better, Kenzo?
Yep.
Cool. All right, so the first thing we're going to do is we're going to call Ceramic create, and then we're going to type tile. And this is ready here already from my completion. So we're just going to create a tile document that has the content hello world. All right, so now we got this back. This is the document ID, and then we get the content. So what we can do now is Ceramic show, and then paste this document ID. And yeah, obviously we get the same content back. We can also show the state of this document at this time, so state. And now we can see that the owner is this DID that we have over here. It's a tile. We have the content of the world and some additional things that I won't go through now, and the log. So the first entry in the log is obviously the ID, the document ID. And the next one is actually an anchor record. And right now in this implementation, we have mocked the anchoring service, but we actually just now kind of are finished the first implementation of an anchoring service, and we're just starting to integrate these two together to have the full protocol. All right, so actually interesting here is that we can, since the DID here is also a ceramic document, we can copy this DID, or yeah, we can copy it from here, and we can paste it, and we can see the state of the DID document. So now we see this is a doc type 3 ID, there's an owner, this public key, and we have a signing key, and we have an encryption key. And yeah, we also have a log and an anchor record. All right, so let's do something more fun. So ceramic change, and we're gonna change the tile. And I think I got something prepared here. Yeah, so we're gonna keep, so basically we pass the new state of the document, and this will generate a patch from the previous state to this new state and create a signed record that includes this patch. So we still keep the hello world and we add more data. All right, so we do this update and now we get this back. Now we can show it again. And we can also, let's see, show the state again. So now we have the Genesis record again, the first anchor record, and then this signed update record, and another anchor record. All right, so now we're gonna do something fun. So I'm gonna copy this latest anchor record, and we're gonna go into the IPLD Explorer. So this is like when you run an IPFS node, you will have this web UI. So we can paste this CAD here, and we can click inspect. I'm just going to move this chat. So now what we see is an anchor record, and we have the previous object or record, and we have a proof. So right now this proof is kind of mocked. So this is like obviously like a fake blockchain anchor. We don't have a real transaction hash here, and we just have like a generated number. But this is the kind of the structure of the proof. And now we can go to the previous record, and here we'll see this kind of update record that we made before. And the content here is a patch that adds the more property and adds data. And we have a signature. And right now this is using JWTs. So we have to store some additional metadata such as a header and the DID. In the kind of more native IPLD signing that we're working on, we don't have to store all of this kind of extraneous data. So now if we go to previous again, we get to the previous anchor record that anchored the Genesis record. And this has a similar proof. And it also has a previous record. And if we go to previous again, we now get to the Genesis record. And here we can see the owner is the 3ID, and the content is hello world, and the doc type is tile, and we also have a signature here. All right, so we can see kind of how we went through the entire path of these IPFS objects that kind of point to each other and make up the state of, of this document that's hello world. And more data. All right. Yeah. That's it for the walkthrough of the spec and the demo. I hope you enjoyed it, and happy to hear any questions you might have.
Yeah, so Eric had one. How would you summarize the problems that Ceramic solves for 3box? So yeah, 3box is going to be one of the things that are built on Ceramic, but Ceramic is not exclusively for 3box at all. So Ceramic enables 3box to migrate a bunch of its logic and centralization vectors into a decentralized network. And so basically, 3box is centralized today, both explicitly and implicitly. So explicitly because we store the mappings from the public keys to a DID on what we call the address server today. And so if you want to look up a DID for an Ethereum address, you have to query some server. And it gives you the DID, and then use that DID to go get the rest of the data. And so we're migrating that logic explicitly into Ceramic with these 3ID documents. And then the implicit logic is that the 3box client, so the JS client, sort of just directly connects to a node running on 3box cloud. And so like that connection and routing logic, as well as some of like implicit schema definitions and way that spaces are namespaced and defined, is all sort of exclusive to 3box. And so we're basically just pulling all of this logic out, including like identities, routing information, schemas, access control policies. And 3box, the framework just becomes super light. Like it is more just like a way to build apps that are enabled by Ceramic rather than like build 3box apps. And so it becomes super lightweight and modular, if that makes sense, Eric.
I guess another thing to add to that. So I showed off the CLI tool. And of course, this is written in TypeScript, so you can actually run the full protocol in a browser as well.
Nice. Thanks, guys.
So quick question just on the kind of TLDR of this. It kind of sounds like essentially every single document kind of gets its own like doc chain almost. And then if you have the ID that signed that, the genesis of that chain, then you can append future blocks onto that doc chain to show the history of that doc. And then you can verify that you have updated the doc according to the doc chain. Is that kind of the TLDR?
Yeah, that's kind of right. And I think that's a good way of like explaining it. The only thing that I want to be careful with here is that, so the problem I described where that's not really a problem for identities is actually a problem for if you want to make a cryptocurrency system. So I would not recommend building a cryptocurrency system on top of Ceramic because that would be insecure essentially.
Well, yeah, and so you guys checkpoint onto a more secure blockchain to take advantage of the security and consensus layer there. And then that way you can just have the Ceramic layer be more lightweight, right? So you can have the doc, and then when you anchor it, you checkpoint it in there via the Merkle tree, and then when you want to update it, you just sign another addition to that doc chain, and then you're kind of good to go. So it's great for docs, not so great for cryptocurrencies because the validators are on the layer 1 system, and this is kind of like a layer 2 system or side chain or whatever.
Yeah, exactly.
Okay, cool. And then also like, so if a user wants to do this, they can do this with their DID. And I think based on the last call, you can have like an Ethereum address that then creates a DID so that you could own your DID via the private key of your Ethereum address. Is that correct?
Yeah, exactly. So the I described like an account link document type. So you can create a 380 380s in Ceramic, and then you can point your blockchain address to this DID. So you can have a pointer from your Ethereum address to the 380.
Okay, so then in this way, like let's say there's like a DAO that has an address that can arbitrarily sign stuff via that key. It could then sign a pointer saying, this is my DID, and then through that DID, sign a series of documents, potentially like the DAO's like operating agreement saying these are the things we do. And then as members vote to update it, they could have a chain showing how that agreement has changed over time. Is that a thing that seems feasible?
Yeah, definitely.
Cool, awesome.
I had a quick question. You mentioned that for a user, it wouldn't be in their interest to do a data withholding attack. But would that not actually be something you might want to do if you wanted to? I'm thinking about reputation. Like if someone's building a reputation based on actions that your idea is taking, you could basically create a fork at a point where you want to go back to, just in case the actions that you're taking negatively affect your reputation, and then all of the things that you've done would be invalidated.
Yeah, I mean, so that's true, but the data that the things that you have done wouldn't necessarily disappear. So if you're interested in like making this reputation system, you probably want to keep that data around. In case there is a dispute, you can like look at that and like make a decision based on that.
But that would make your key revocation problem hard, right? Like if you then claim that someone stole your identity, would be the same as if you'd been trying to attack it yourself.
Yeah, I mean that's a problem with like negative reputation, and I think the negative reputation thing is also kind of very much discussion if that's like something that's like even a good thing. But yeah,
there might be another way. So I'm unmuted. There might be another way too, like where there might be just like a reputation document that others may just like append to for an app or something, where it's just referencing others. So it's not actually the document controlled by the user. It's sort of like another document feed that references the DIDs of users that you can sort of look to as a reputation feed. That's sort of not censorable by any particular user. It's like a different source of data that you can use to build a reputation system, if that makes sense.
Yeah, that makes sense. Thanks.
Cool. We got a question from Mark, Joel.
Yeah, let me read it. Are there any ideas / proposals that have come in with regards to OrbitDB? Anything we can do to support this effort in terms of baking in things that should be in the library versus being in Ceramic? Yeah, so there's been some like thoughts and ideas in the community, and we also have like been thinking about how we can integrate it. I'm not sure what you mean exactly, what should be in the library. I'm not sure which library you're referring to. I don't know if you want to clarify the question a little bit. Oh, I remember you typed something about not having a mic. So, but yeah, let me, so what we have been thinking about is basically using these kind of ceramic tiles as a way to kind of point to an address of an OrbitDB database. So you might have an address, you create like an OrbitDB database, and then you get like an address of this database. You would store that in your tile, and then in this tile, I could also store like this particular OrbitDB database is pinned by this service or these two services, so I can connect to them directly to sync the data in that OrbitDB database much faster. So yeah, that's kind of how we're thinking about the separation of concerns. So like we use like Orbit, but to like more fast-paced and like more general database operations, but then in Ceramic with kind of pointers to the databases and also like pointers to like the service providers that like help you pin and provide additional services to that database.
And it might be interesting to think about like how potentially these OrbitDBs can be like snapshotted into Ceramic somehow. That might be cool too.
Yeah, that's interesting. I hadn't thought about that.
Yeah.
Okay, there's another question regarding the bandwidth. So now every update of the document will be anchored to show some blockchain. So yeah, that's right. So when you make an update, there will be an anchor in one blockchain. But as I mentioned, this anchoring service can actually anchor a lot of different updates, and there might be like multiple anchoring services. So so basically, that can scale fairly well. I hope that answered your question, Pavel. Cool.
Does that mean that anchoring services are responsible for making sure that the data is available in IPFS?
So right now, there's no like guarantee of data availability of any particular document, and you might imagine like a case where, so I ultimately for the documents I care about, I'm responsible for like pinning them, or I might like outsource that to some service. But the cool thing about like storing the data and the whole Merkle tree in this kind of IPLD structure is that even if we go offline, I can still sync the entire chain of the document and even the proofs to you if we have some kind of Bluetooth connection or something. And you can verify that up until the kind of verification on the blockchain.
Okay, yeah, that makes sense. So if you're trying to verify a document and the stuff isn't available on IPFS, you can talk to whoever controls the identity and say, look, I don't have the data that I need. Can you find it somewhere?
Yeah, and that part is like solved kind of by IPFS because you can like kind of request the data through there.
Yeah, perfect.
All right. See any other questions? And mostly back and forth. Any other questions about how ceramic works or what it can be used for or in general?
Cool. And we're always available in Discord and on GitHub. So you can always ping us there and drop by, say hi, share some use cases. We always love to hear those because it helps us flex the protocol and make sure it's maximally general. And I'll share, what would you build with it besides 3box? I'll just wrap up here and then I'll answer that. But yeah, so I'll share this with the community after too. So you can always go back and watch it if you need a recap. But so the last question, what would you build with it besides 3 IDs? So 3 IDs are just one doc type, but like tiles are a really general doc type that have no particular use case rules. So tiles can represent data schemas. They can define a data schema that is versioned and updatable, and even referenced in other tiles. So whatever you can define in a schema, you can use for a tile. You can use it for general publishing of content. You can use it for storing service definitions and service policies. You can use it to store membership lists. You can use it to store social graphs. You can use it to store any data that generally needs to live outside any particular silo, whether that's a blockchain network or a server, and sort of put it in the public domain where it can be universally accessed. And you can always be sure that the links that represent that document will never change. So it's just like a very general framework. And so it's sort of hard to describe all of the use cases, but the ones that we're sort of working with first, because we've been working with 3box, are sort of like the migrating 3box to it. But there's so many other use cases that people are already thinking. Publishing a history of corporate environmental tragedies or something like that that need to be censorship resistant and a public data source about that information. So there's a lot of stuff.
Yeah, I really liked another one where it was based on like kind of you have user interactions that are anchored on ceramic, and then you run you have like a DAO that runs SourceCred, which is like an algorithm for calculating kind of or distributing tokens based on like the social interactions between people. And you could like build any type of like really verifiable interactions on ceramic to like basically register like who was part of like making this event happen or something like that. And you can like make automatic like payouts of tokens based on the work you've done and like verified in ceramic. And that's really cool, I think.
Cool. All right. Any more questions? Then yeah, I'll see you guys online. Feel free to drop by Discord.
Yeah.
Bye-bye.
Thank you.